2020. I know that these have been 3 full days, but I hope that you enjoy them and that you learn new things that will be useful for your work. Before passing the floor to Tiziana, that is moderating the final session to our guest speakers, I would like to announce here the winners of the best poster and demo competition. And I would like to thank all the people that spend time in voting online for this, and all those that have submitted posters and demos for this EOSC-hub week. So for the best poster, actually, so when we were thinking about the award, one of my EOSC-hub colleagues suggested that the best award should have been to frame the poster and ship it to Karlsruhe, that initially was the original venue of the EOSC-hub week, with the following message. I almost went to Karlsruhe for the EOSC-hub week 2020, but all I got was the best poster award. Well, so in the end, we decided that the awards for the best poster and the best demo winners will be free tickets for the final EOSC-hub event that we are going to announce at the end of this session. So then I'm pleased to introduce the best poster winner. So the best poster award goes to the BI Enterprise Content Management, and I would like to invite EuroGEOSS Niemic. Apologies for my pronunciation. EuroGEOSS is Solution Architect at BI Insights, and I would like EuroGEOSS to briefly describe the content of the poster. So
yes. So, hello, good afternoon. First of all, a big thank you to all of you who voted for us. I have seen some of the competitors, and I have to say it's a great honor for us to win here. I would also like to thank EOSC, DIH, and DEEP team, Marcin, Agnieszka, Eliza, Alvaro. Yeah. I have the honor of presenting here, but it would not be possible without the team who stands behind the system that we designed. So I would like to name them here. I need some support. It's a long list. So thank you, Dorota, Magda, Małgosia, Mateusz, Vlad, Szymon, Piotr, Krzysztof, Marcin. Thank you, guys. So we designed a system that is that can help organizations manage their unstructured data that is naturally hidden in departmental silos and is not easily accessible to all the members of the organization. So the goal of the system is to create an information hub where the data from internal and external sources is centralized in a central repository, and the knowledge is extracted from the files automatically, and it can be shared across the whole organization. So the system can connect to many popular data store types, searching for new files, which then go through a natural language processing pipeline, and artifacts extracted automatically from the files are stored in a document database and in a search index. So now I will switch to a short live demo of the system. So here you can see a system that has been preloaded with almost 50,000 of documents generated by Polish Parliament. These are acts of Parliament. So we can quickly search sorry, the documents are in Polish, so maybe you will not understand the content, but the system is bilingual, so the menus and all the labels are in English. So I'm searching for European Union keyword. This is Unia Europejska in Polish. So, and if we go to the document details, we will see the keywords generated by the system and all the metadata that was extracted automatically together with the summary. Yeah, and let's try find something about EOSC. And we find one document, but this is just by coincidence because the system is correcting the user spelling mistakes. But we can go and search in external data sources that are integrated into the system, for example, OpenAir, and here we can see something much more interesting. And we can click on the link, which will lead us to the source system where we can read all the details. So I will now switch back to the presentation. And we are still improving the system. We are planning to add new features like more text analytics and advanced image processing, including search with picture and documents semantic similarity networks. And we are almost ready to launch a demo in the EOSC platform, and we will load some English documents that would be more meaningful and maybe useful to the EOSC community. And I think that's it from my side. I hope I did not run over the time. Thank you.
It was perfect. Thank you very much.
Yeah.
So congratulations once again. And
Thank
it was
you.
very nice. Okay, so let's move then to the best demo. So the best demo goes to the Deep Hybrid Data Cloud, developing and deploying your deep learning application. And actually the award goes back to Karlsruhe because we have here Valentin Kozlov, that is a researcher in the Data Analytics Access and Applications Department at Steinbach Center for Computing of the Karlsruhe Institute of Technology. Valentin, the floor is yours. Yeah.
Good afternoon, everyone, and thanks a lot for organizing this EOSC-hub in these not so easy times. And of course, great thanks to everyone who voted for our demo. And well, the award doesn't go only to Karlsruhe, it goes to, of course, all the people with whom we work in the project and who developed the solutions which we are presenting together also with my colleague Lara from Spain. So in our demos, and first I want to shortly introduce our project, Deep Hybrid Data Cloud, where DEEP stands for Designing and Enabling Infrastructures for Intensive Data Processing in a Hybrid Data Cloud environment. This is one of the European projects, and where we have 9 academic partners and 1 industrial partner. And then the goal was to prepare a new generation of infrastructures with different latest generation technologies, so leveraging also hardware like GPUs and InfiniBand to support deep learning and other intensive computing techniques to exploit very large data sources. And we wanted, and what we worked for is to make it easier for scientists to integrate their applications and transparently run them on different infrastructures, exploring cloud environment and HPC environment, that they can easily prepare their modules and share them with other people in the catalog or marketplace, and that they also leverage DevOps approach and continuous integration and delivery. So we have several deep learning use cases which cover different fields of science, and this is biology and, for instance, plant classification. This is also, there are applications for classification of seeds, phytoplankton. This is also satellite imagery, massive online data streams, and for instance, retinopathy to detect the level of retinopathy in patients. Then, in fact, our solutions are leveraged by quite a number of other communities, and the whole list is beyond the use cases which we started with in the project, and you can explore many of them in our marketplace. If I now switch correctly, just to show the marketplace, where you can then, for instance, well, go to an application and you have a possibility to deploy it immediately for training. You get the information about the application itself. You can also access the source code and the Docker image of the application, but you can also submit it for training. Then that's a big figure which is now loading with, just to give you a short view on our architecture. I hope the figure loads. But so in the project, we use different technologies and solutions. There is a path orchestrator, there is a Indigo orchestrator, well, which is based on Indigo orchestrator. There is a dashboard, there are dashboards, there is Alien for Cloud. We also leverage one data storage solution from the XDC project, which was presented also during this week. We use a UDocker tool, or we developed this tool actually, in order that the user without escalating privileges can run Docker containers also in HPC multi-user environment, and so on. So sorry, the figure didn't load for some reason. But then in short to what was presented in the demo, that there are three, let's say two different possibilities where people can deploy one of the deep modules hosted in the deep open catalog, either in cloud or HPC environment. So when we go to cloud, we first can select the module from the open catalog, then use the dashboard to deploy it in our test bed. And for instance, one of the modules is actually deep development environment, where you can start developing your own application, and then you can do training and you can do inference. And since this is based on Docker images, you can also do the same stuff in your local computer. And then in the HPC environment, we have two parts, where first part where you can log into the HPC system using your OEDC token, so not like login and password, but we have also central IAM service, and then we can basically use these OEDC tokens to log in to identify ourselves in different services, and including HPC system. And you can do very much the same. So leveraging UDocker tool, you can also submit this deep development environment as a Slurm job, and then by doing SSH tunneling, you can access this environment and work directly in the HPC system. And in the second HPC part, we do pretty much the same, but using the path orchestrator dashboard. So the web interface where you configure your deployment and you submit that to the HPC system. And there we also use one of the applications, which is in our open catalog, retinopathy, and where the data for this application is hosted in OneData, and just by configuring through the web form, you can make a deployment to HPC system, Slurm system, and starts and immediately processes your data stored in OneData. So this is more or less it. And here I just show some links where you can find more information about the project, the main web page of the project, the marketplace, also the open catalog. We also provide a DPass training facility in the EOSC portal, and there is more documentation and description of UDocker tool itself.
Excellent.
Thank you for your attention.
Thank you very much, Valentine, for this brief introduction to your work. So I would like to thank once again Valentine and Jegos for this presentation. And then I think it's time to move to the final session of the closing plenary, focusing on the EOSC-hub contribution to societal challenges and the role of digital infrastructures. So I would like to introduce the moderator of this session, Tiziana Ferrari, Managing Director at DGI Foundation and also EOSC-hub Coordinator. Tiziana, the floor is yours.
Good evening, everyone. It's a pleasure for me to be here at the closing plenary for this virtual conference. And also, I'd like to thank many of you that I see are still connected. I hope you are going to enjoy the interviews that we're going to have in this last hour. Our objective, this closing plenary, is to bring science in focus and to show how concretely scientific communities through the European Open Science Cloud, through e-infrastructures, can address the societal challenges. So as the moderator of this last session, I'd like to introduce our guests. First is Alexandre Bonvin, here representing structural biology as a scientific discipline. Alexandre is a full professor of computational structural biology with the chemistry department of the Utrecht University. He's also scientific director of the Bijvoet Centre for Biomolecular Research, in which structural biology and the study of interactions between molecules is central. The second guest is Richard Lucas. Richard is holding a circumary research chair with the Earth Observation and Ecosystem Dynamics Research Group with the Department of Geography and Earth Sciences of the Aberystwyth University in Wales. And I've challenged my Welsh pronunciation here. So with Richard, we will be exposed to a completely different sector. We will look into sustainable development goals and ecology. So I hope that you will enjoy this interview with our guests and also learn how real in daily life EOSC can support experiments and excellent science. So I'd like to ask my first question to Alexandre. So Alexandre, in a few words, can you introduce your scientific activities and the WeNMR community that you are representing here?
Of course. First, let me thank you for the opportunity to speak here at this plenary. It's a real pleasure. So I'm representing WeNMR, which is a virtual research community in the area of life sciences in general and structural biology more in particular. We are linked to the Instruct-ERIC project and also ELIXIR-ESFRI project. And as WeNMR, we are serving a large worldwide community of researchers who are working on all kinds of problem links to molecules and how molecules interact with each other. And we are providing compute services, actually thematic services under the EOSC for users to transform their data into models using high throughput resources. So the portal that we're operating operated from Utrecht University, but also from Florence. So there are different geographical locations. We have accumulated since now more than 10 years of operation, basically under different projects, more than 17,000 registered users. And these are generating a lot of computing jobs on the EOSC resources. Those users are coming from Europe, but also the majority actually is from outside Europe. So from Asia, the US, so we are covering more than 110 countries. And in terms of also impact these days, we see a large use of some of our services these days to fight COVID actually, because this is the area of structural biology, drug design.
Yes, we will see just in a few minutes from now how practically an experiment, which is so actual, will benefit from Haddock in the demo. So I'd like to turn to Richard. So Richard, you have been, I hear from your bio, one of the main contributors to the EODESM system, and also through the Ecopotential project, you have been contributing to EuroGEOSS. So can you say something about the project, your activity, and EuroGEOSS? You're muted, Richard?
Yes, thank you very much again for inviting me also. And most of my experience is in quantifying and understanding the response of terrestrial and coastal ecosystems environments to change through integration of Earth observation data from multiple sources. And we've looked at all sorts of methods, looking from the scales ranging from trees to the globe. And as part of the Ecopotential project, we developed the Earth observation data for ecosystem monitoring. And that allows routine mapping of land cover and change based on evidence through retrieving environmental variables from satellite data. So we don't classify really the images, we bring the environmental variables together, and we then combine these to produce land cover maps and also change. So we're leading a project called Living Whales as well, which is a follow-on, and we're significantly advancing that as well. Basically, what GEO, the Group on Earth Observations, is very, has selected the United Nations Sustainable Development Goals as one of its engagement priorities. And EuroGEOSS is the European regional component of GEO, with a focus on coordination and scaling up these user-driven applications being developed in Europe. And so I believe we have a video that can explain that a bit more to show. Is that right?
Yeah, thank you, Richard. So as anticipated, we have a short video that can give you a practical understanding of how important is addressing the societal challenges, especially UN development goals. So please.
Fire risk depends on many factors, including climatic conditions, vegetation type and amount, forest management practices, and other socio-economic.
I think Sara has to fix the presentation layer. So let's see if we can, yeah.
Fire risk depends on many factors, including climatic conditions, vegetation type and amount, forest management practices, and other socio-economic factors. Climate change projections suggest substantial warming and increases in the number of droughts, heat waves, and dry spells, especially in the Mediterranean region. Italy's forest estate is one of the largest in Europe. Preserving and enhancing forests is also important for society and economy. For this reason, local authorities are deeply committed to forest preservation and fire risk prevention. On the 24th of September 2018, a large fire devastated the forests in the mountains north of Pisa. The mayor of Calci, the closest city to the fire, highlighted that it was difficult to estimate the extent of the fire, but that it was surely a huge portion of the forest on Mount Serra. Earth observation helps monitoring the extent of burnt areas. The EODESM model classifies land cover and land cover change. EODESM runs through the virtual laboratory VLab, which uses European cloud platforms, including the Copernicus Diocese and the European Open Science Cloud. By using EODESM within the VLab, the extent of significant change near Pisa was mapped from Sentinel-2 images acquired before and after the fire. VLab enables other scientific models too, in particular Trends.Earth model, which calculates the UN SDG indicator on land degradation. EuroGEOSS enabled the connection among the presented European capacities for forest fire and land degradation assessment.
So the the video shows how Earth observation and Earth science modeling can provide knowledge for decision makers, in particular for SDG 15, which is life on land. And more specifically, it shows how European capacities may contribute to European resources. Using the showcase are Sentinel data, digital infrastructures, including EOSC, and functionality created through the EU-funded research and innovation action with the BioLab and EODESM.
Thank you, Richard. I'd like to go a bit deeper exactly on this very topic. So looking at specifically how digital infrastructures and I would say also EOSC-hub have been enablers for the scientific activities of both WeNMR and EODESM. So I'd like to turn to Alexandre. So Alexandre, can you tell a bit how WeNMR, structural biology, and also the research projects you are supporting in COVID are depending on European digital infrastructures today?
So if you look at our thematic services, we could not offer the amount of services and the quality of services if there was not an infrastructure behind those. And we are making extensive use of the high throughput compute infrastructure in EOSC. So that's our model or our jobs in terms of thematic services are mainly not so much data dependent, but we rely on a lot of computing for that. And the high throughput computing is key for that. Another important aspect of EOSC is to facilitate our task to dispatch all the computing to the distributed resources, high throughput resources. So as thematic service provider, we are in between the end user who are using our services and the infrastructure. And we have to communicate with the infrastructure. So the tools like Dirac for EGI are crucial for operations. We use a bit of data, but it's not that much. So it's really the access to the resource, making sure that things are working, getting the support where things are not working, because the world is not perfect. So there are glitches from time to time. So having a quick response to ensure that we are 27 in operation is also important. And we could not provide these services if there was not an infrastructure behind it.
Mm-hmm. So I think probably WeNMR with your application suite is a very good example of how the complexity of digital infrastructure can be mediated and made accessible to the researcher without a major IT hurdles. So same question to you, Richard, because you have been very active. We have heard about EODESM, and it's actually a virtual lab. So how digital infrastructures and EOSC-hub have been supporting you?
Yes, we're currently using EOSC as a provider of the computing resources through its infrastructure as a service capabilities, and specifically to allow execution of EODESM. The digital infrastructures allows the scientists and decision makers through dedicated user interfaces, which we have here, is to run complex models of applications such as EODESM, and without the need of sort of setting up, their own infrastructures. And so this really enables complex scenarios to be undertaken through collaborative research. We can work with people, reproducibility, replicability, and reusability of the research outcomes. So people can access and use EODESM and for practical application as well through this system.
Okay, thank you, Richard. I think in my next question, I will go into the future challenges for both of you, but before we have prepared a couple of demos. So first, Alexandre will show through one specific application how scientific projects can be supported, and then we will go into the specificity of the specific cases of EODESM. So we are planning live demos. We are very brave this evening, so I hope technically everything is going to go smoothly, and I'd like to give the floor to Alexandre to show how, in practical terms, how this works.
Okay, so I will share my screen, and I hope indeed it's always scary to do a live demo. Murphy tends to pop up at these times. So I'm sitting in the dunes on an island on the North Sea, and I will show you how we can actually use EOSC real time in real life. At least I hope to. Okay. So if everything goes right, you should be seeing an empty screen right now, my screen actually. So the use case I'm going to demonstrate now is COVID related. Everyone is of course aware of the current pandemic. And what you are seeing on screen now is a structure of a protein from the virus, the one that you see in a kind of violet, light violet color. That's a domain of the virus, the domain of a large protein of the virus, the protein that you all know if you know the picture of the virus, that like the spikes that are on the outside of the virus. Now, the way the virus penetrates our cell is to interact with a receptor, which is another protein, which is sitting on our cell. And the green ribbon representation that you see here is actually the receptor on a human cell. So this is the first step in the infection process by the virus. So now we could think of a strategy to combat the virus, to compete with the receptor. So for example, see if I was to extract a small substructure from our receptor, in this case an helix, and I could try to design a peptide that will bind stronger to the virus than our own receptors. So if you could use such a peptide, it will compete with our own receptors and prevent the entry. So we are now in a field of, say, protein engineering, which is relevant for COVID, of course, but it's also used in all kinds of other life science applications. So one way will be, for example, and you see now a yellow part appearing to do a mutation in this peptide, replacing an amino acid. And now the question is this a good choice? Is this a smart mutation? Will it lead to better binding of the peptide to this viral protein? Now, that's a question that we can try to answer with one of our tools, haddock in particular, which is a tool we have been developing in Utrecht for almost 20 years by now, and which has been offered as a web portal to our users using the EOSC infrastructure for more than 10 years. So I'm going to demonstrate to you how this could be done. So now I'm switching, and so I'm a, say, user. I've heard about EOSC as a tool or European infrastructure. So I'm going to search for EOSC, and I've heard about haddock as well. Now, you see the first page, and the first page have all to do with EOSC and haddock, so that's good. So we are well visible. And actually the first link in this page points me to the EOSC marketplace and haddock. So let's go there. And I'm getting this page, which tells me, okay, I'm on the European Open Science Cloud, processing analysis as a service, and haddock for the integrative modeling of biomolecular complexes. So let's, well, agree to get rid of this, and now I'm accessing the service. This brings me to like an intermediate step. There is no need here in principle for applying for the service directly from the EOSC, but users will have to register first to be able to use our services. So let's go to the service. This brings me, got it, to the haddock portal. And what you are seeing here is the haddock portal version 2.2. Now, for the sake of this demonstration, I want to present you a brand new portal, which is the haddock 2.4 portal, which, if everything is correct. So this is the entry point in Utrecht for the thematic services, the EOSC WeNMR thematic services in my laboratory. So now I'm going to scroll, and we see that we have actually quite a number of services that are operating from Utrecht, and the one that we are interested in is haddock. Now, before being able to do any submission to these portals, I need to be registered, which I am, of course, but I need to log in into the portal. I click on the login window, and you see another component of the EOSC infrastructure, which is the single sign-on component, the EGI check-in. So now I'm going to connect to the portal, and the goal here is to use my university credentials to do that. So I'm working at Utrecht, and Utrecht University is here. So this is bringing me to my university login page. No typos, fantastic. So it's connecting me to the EGI check-in. Yes, continue, I'm fine. And if everything goes right, the portal now tells me you have been successfully logged in. Good. So now I can go to the ad hoc portal and start trying to answer this question: was the change I make in this peptide good or not? So we're going to submit a new job. By the way, you see here also BioExcel showing up. So ad hoc is a core software in the BioExcel Center of Excellence project. So let's submit a new job. And you will see that in these steps, there's quite a lot of parameters that a user can change. So this is EOSC demo. I have 2 molecules. I'm going to submit it. So I need to upload a file, which could come from a database, but in this case, it's my design peptide. And I want to use chain A from that one. So this was the peptide from the human receptor. So now I'm going to give it the viral protein, which is chain B. Next. So the data have been already validated. The portal presents me with a number of options. Nothing needs to be changed for this particular use case in this case. And now I'm getting into another page which offers a lot of options and parameters. And I'm going to change them for the use case that we want to do. So we don't want to model from scratch the entire interactions. We just want to basically refine this new mutated complex and define if this is a good solution or not. You see a lot of menus that are clickable that expose all kinds of parameters. So while I'm changing the parameters to something which is sensible, I could probably do anything because there might not be many experts that are understanding what I'm doing. But what you see, another component of basically running thematic services is that you need to provide training to your users. Users are not going to use the resource without a proper training. So that's also a lot of investment in time, in effort. You need people to do that. You need to put tutorials online so that people do the right things. And you also need to be ready to answer a lot of questions. So everything is ready. I can submit my computation to the portal. And now since the beginning of April, we have added options to tag our jobs as being COVID-related research. So this pop-up window appears. Is this a COVID-related research? Yes. And now the job is being submitted. So you see it has been successfully processed, and at some point it's going to start running on the grid. Now this COVID tagging that we added in the last months basically allows us on the back end to send the jobs to sites, resources that are specifically supporting COVID-related research. So with the negotiation between EOSC and EGI, we gain access since a month now to the US Open Science Grid resources. And we have several high energy physics groups that are physics sites that are providing resource for this kind of COVID research. So now we don't need to wait for this job to finish because it will take some time. So these are not question of seconds, but I have some pre-calculated results we can go to. So I'm going to the job information. So this is the one I just submitted. And here we see a previous run. And this is bringing you to the result page, what the end user will be presented with. Users also get notified by email. So it's a very user-friendly way of dealing with complex workflow, complex computations, which completely hide the complexity of high-throughput computing to the end user. So the user can look at these results. We have some citations, or proper citation of the European projects and sites that are supporting us. We constantly monitor the satisfaction of your users. And then you are presented with results, statistics. In this case, you see here a score. And this score would need to be compared with the score of the wild type protein, the unmutated one. And actually, I'm not going to show you the comparison, but this is better than the receptor in our cells. So yes, we have improved the peptide and maybe we can do more mutations. This is of course all in silico predictions. We need to do experiments to validate those things. Another feature of the portal, we can look at the structure directly online from the web browser. You can see here this particular residue. Of course, when I move my mouse, connection might be a bit slow, but this is the mutation that we introduce, and yet it's there. So now I mentioned in my introduction that we have a large user community. So I'm going to bring you to a statistic page, which is online, so everyone can look at it. So these are the number of user requests that are actually active on our portal. So we have 2 entry points. So you see there's about 120 that are actually active. There's a large number which is queued. You can find here the total number of jobs that have been served on the portal since the portal have been running in 2008. So it's more than 270,000. And each job submitted to the portal might translate into 1,000 high throughput jobs being sent to the EOSC high throughput resources. You can also see here that we are monitoring COVID-related research since a month now. And we can also have a look at the worldwide distribution of our users. So you see a map. Let's sort the users. So you see the total number of registered users for all of the WeNMR thematic services is reaching almost 18,000. We have seen an increase in registration in the last months because of the COVID pandemic. So a lot of people are doing COVID-related projects. All together, Europe aggregated is the largest community, but you see that Asia is following very closely and the US as well. Now, finally, I'm going to show you actually real-time statistics about jobs that are running now. Actually, this is the statistics from last hour. So this has been running on the EOSC resources. So we have about say more than 2,000 jobs, and in this case, it's about 1/3 of the jobs that have been running for the last hours were COVID-related one. Where have those jobs been running? This is the distribution again over the last hour over sites. So half of them have run actually in Karlsruhe, which is good in the context of the EOSC week. We don't predefine where jobs are running, so we are using more an opportunistic computing model, but Dirac for EGI does all the magic for us and distributes where there are resources. So currently, KIT is giving us a lot of resource. This is specific also for COVID-related research, like the high-energy physics sites in Marseille, which put up resource specifically for COVID, but you also see the Dutch resource very importantly represented there. And finally, the last bit I want to show you. So this is the number of jobs that have been running on the infrastructure for the last 30 days. The violet color that you see there is related to COVID research. So these are all jobs that have been tagged as COVID over the last months, and this represents a significant fraction of the jobs. So with that, I want to conclude this demo, and I hope that I gave you a real-life example of what the server, the thematic services can mean for users, for also a real-life important research question related to COVID pandemic. Thank you very much.
Thank you, Alexandre. And I think today we have beaten the Marflow completely. So it was a good demo, and thanks for this journey from science to infrastructures. I think this is a really nice and clear representation of the need of science in a specific domain. I like to go to Richard, and we are again moving to a different domain with ecology and the climate and environment. So Richard, we'd like to hear about how your science works and how EuroGEOSS is practically supporting it with use cases. To you.
Yes, a completely different scale. We're looking at the globe, and basically one of the ideas is with EuroGEOSS is that we focused it initially on national parks, but as a result of the EOSC and the facilities there, we've been able to apply it for any location in the world, and there's still a lot of refinement that can be done with the technique, but it's been very well developed over the last year. So basically, EuroGEOSS is a complex and an expandable system, which means you can keep on building on it. So it's not something that's going to go away. And it generates land cover and land cover change maps based on the Food and Agricultural Organization land cover classification system. What I'm going to show you now is some demonstration of that. And as I say, it was originally developed for these national parks, but one of the things that we tried to access was the Sentinel-2, which is the satellite data from the Copernicus program, and to try and access that archive directly and produce EuroGEOSS and using that data without actually having to download it. So the classification and the change maps are generated that way. The VLab is a technology that implements an orchestrator for automating the configuration, coordination, and management of the online accessible systems. And it's very, in the following demonstration, I'm going to show the potential of EODESIM and the virtual lab to address some of the issues that are relevant to sustainable development goals, for example, looking at impacts of climate and how forests can be used. And we've got examples of impacts of bushfires in Australia's forests and Hurricane Dorian on the Bahamas. And I'll also show you how commercial harvesting of forests can be monitored using EODESIM to support sustainable use, using an example from the Matang Mangrove Forest Reserve in Peninsular Malaysia. But first of all, we'll show you how EODESIM works, and Mattia Santoro is going to drive the demonstration. So there we go. So basically, the first thing we can do is we go to the website and we select our region. And we originally, I say, we've looked at mountains, for example, and we have a choice there of the national parks that have been predefined, like Grand Paradiso. This is where I originally focused our studies in ecopotential. So we choose Grand Paradiso National Park. We select the model, and you can choose your region of interest as well. The model is EODESIM. And you then select the date, and we're going to select the 1st of May 2018, and you choose the image from the archive, and we found a nice clear image here. And then we do the second date, which is the 1st of May in 2019, and again select the image. So you've got two images, and you're going to be classifying each of those and then looking at the change between those. So you can review the, you select the platform. These are the area of interest. You select the platform, which is the EOSC. And then you can then run the model. So we've got this model. It takes a while, as with the other model you saw previously. So we're going to go back through the history of what we've done before. So what we'll do is we go to Grand Paradiso, and this experiment shows the result of what we are running currently. The main land cover in this particular type is water, which appears as blue because it's actually snow, but it's classified as water in the FAO. As you go into more detail, you actually put it into water in a later, more detailed version of this. And the classification says based on the FAO land cover classification system, and there's 8 classes which are mapped. And you can see natural water, and basically that's snow. And there's 8 classes there, and forest and herbaceous vegetation not separated. So you're not separating out forest in this particular legend, but that can be done at a later stage as well. Now, the legend 0 and legend 1 show you then the land cover, the legend for the 2 land cover classification for period 1 and period 2. And then there's another legend, which is associated with result 2, which shows you then the change. So in effect, you have 8 level 3 categories, the 8 we talked about before, and we can basically compare them over time. So each of these are associated with a range of drivers like climate, economic, and associated pressures, like demand for land or increase in temperature, and impacts on the environment. For example, if we have a change from natural terrestrial vegetation to bare or sparsely vegetated surfaces, this can be associated with a loss of vegetation, which is the impact, but the pressure is, say, deforestation. But each of those squares actually represents a major change in the land cover, whereas on the diagonal, actually, it represents no change in the land cover, but internally you could have a change, say, the canopy cover, the canopy height, and so on. So basically, that change approach is very consistent and aligns with a lot of the political frameworks relating to the SDGs as well. So beyond the national parks, we're taking now to the Australian bushfires, and these were large and severe in early 2020. And so we'll give you another example here in the history section, which goes to the Australian bushfires in New South Wales. And they caused extensive damage to many forests in Australia and unprecedented loss of biodiversity. And the rainforest areas were particularly badly affected. A lot of the forests like eucalyptus are are they can adapt, they're adapted to fire, but the rainforest is not. And so a lot of those were destroyed. So between the 15th and 11th of February, you can see now this big change from the green of the result 1 to the complete loss of forest in result 1. And it was basically saying it's converted, a lot of that's converted to sparse or no vegetation. And the result 2 is the change, which is your 8 category change. So if you go to results 2, and that shows the extent of bushfires. And I was actually visited there in March, and that is a very good representation of how massive that burn has been. But what we can also do is see, we saw a lot of recovery from these trunks, the tree trunks. They sort of tend to grow up from the tree trunks. So we can look at what is called the recovery now. So we've taken the image on the latter date, which is the 24th of February, which was just after the fire. And we just looked on the 9th of May, which is like, about a week ago. And you can see now that it's actually coming back. The cover is starting to restore, and you're starting to get some hope now into that area where, we could see that in the field, and it's really nice to see. It's not all coming back. Some will take decades, but at least it's going greener. The next example is hurricane damage in the Bahamas. And there's an interesting hurricane coming up now. It's a storm in which is now hitting Bangladesh and so on. We can look at that storm maybe in a couple of days' time and see what the damage was. So this is what we did with Hurricane Dorian in the Bahamas. So on September the 6th of September 2019, a lot of the Bahamas was devastated. So we look at the Bahamas before with our land cover classification, and then we look at it afterwards, and you can see that there's obviously a big change in the land cover, and then the results, which is the change, and you can see the legend there. That's number 2, results number 2. That shows that there's extensive flooding and there's damage to the vegetation in the urban areas. So there's been a lot of flooding in there, and that actually aligns very nicely with NASA's assessment of where the flooding was. But we've actually also captured more than just the flooding. We've captured the change in the vegetation. The 64 change categories are captured through that. We can also look at then what's happening in the recovery of those areas. I believe we have an example in the history of the Bahamas recovery. We just picked that up again, a week ago, and you can see now it's still pretty sparsely vegetated there, but there's actually more vegetation coming back. There's a recovery of those areas. So what we can do is we can choose anywhere in the world, anywhere in Europe or India or whatever. We can choose it. We're providing a basic classification at the minute, but we'll talk later on about how it can be advanced. But that's the big thing. We've gone away. We can support the national parks. We can support anywhere globally potentially with this. And we're making significant advances in the higher level classification with this, which we also want to run through as well. The third example is, well, should be the fourth, because it's about the mangroves in Matang. Basically, the mangrove forest reserve in Matang has been in commercial operation about 100 years. So it's one of the oldest commercial forests in the world. And we've been doing quite an extensive project there involving the virtual lab and showing the Malaysian people how it works as well. And we can see how they log on a 30-year cycle, and we can see the logging coops. So we'll be zooming in a minute. You'll actually be able to see the individual logging coops. So they have the forest, they cut it down for charcoal, which interestingly goes to Japan, a lot of it, but also for poles, for construction, and so on. And you can see now that these coops are appearing in the mangroves. And they regenerate. They take about 30 years to regenerate, then they clear them again. So this system allows the forest managers to say, okay, what's being cleared, this week? If the clear image comes in, what was cleared, they can track it because they've got a lot of commercial operators there, and they can check them with this, for example. So, and also what they can then do is also track how the forests are recovering. They can actually then use that to say, well, can we sustainably manage the forest? Is the forest being sustainably managed? And so we can track all sorts of aspects in there as well. So this is the very upper level part of the framework, but there's a very deep framework which can go much further in and use the power of the computing facilities that have been provided here to produce a sort of endless supply of land cover and change and contributions to looking at future environments and looking at sustainability. So it's a very exciting a way of doing things, and the platform gives a great way to allow people to just look at what's happening. So if you want to see the impact of the cyclone tomorrow, just go and have a look through this platform.
Thank you, Richard. Was again another inspiring demonstration, and I think with this second demo, we can also see how scientific data can support policymakers and how impactful this is for all of us as citizens. So yeah, very nice presentation. I'd like to encourage our audience to perhaps post some questions in the chat. We are pressed by time, but while we wait for a few questions appearing in the chat, I'd like to ask my last question to both of you, Alexandre and Richard. So the question is, what is coming in the future? So if you can say in few words, what is the biggest challenge, and this would be useful input for the infrastructures and EOSC, I hope, to define our future actions. Alexandre.
So, well, one challenge for us is to keep having software and services that are top of the line and upfront in terms of science that they are covering. Because if you have something fantastic today, you still want to have users 5 years from now. So it means that you cannot just put a service out there and let it go. So you have to constantly improve it. So that's not so much for the e-infrastructure, maybe a part, but projects like BioExcel are contributing to that. Further, for us, it's important to, so I think in my demonstration, it was clear it's more about the computing. The data comes from the user, and each user comes with a different set of data. So we hear a lot about data in the context of the European Open Science Cloud, but without computing, you cannot process or analyze any data. So the computing is important. It has to be there, and it has to remain in the future. Should it be grid or cloud, it doesn't really matter. Dirac for EGI is ready to access both. So for us, our life is easy. What is also important to realize, I think, in terms of European landscape, is that all those nice services that are put by all the different projects to target the users, they are not going to run by themselves. You need an infrastructure to run them, of course, but you also need a manpower and people to make sure that the service is running every day, to answer user questions when things breaks down, to contact the infrastructure provider when there is a problem. And this is not happening by itself. So operating services does require manpower. And this is something which is not always very visible in the current funding. So we are speaking a lot about virtual access, but we as service provider, we cannot make our user pay for the access. I think if tomorrow Google is asking you to pay for each search that you are doing, you're going to use a different service. So we are sitting in between the infrastructure, which has cost associated with it, and the end users. And we need to be able to keep providing the services. And I think also an infrastructure, a fantastic infrastructure without usage is also completely useless.
Yes, thank you, Alexandre. I think the message was clear. We will make sure that EOSC-hub will bring this to the Commission, but also to our partners and the future EOSC legal entity. So, Richard, what is your request for the future? And
well, I think one of the things is, like, you develop something like EOSC and what you need, and we've been successful to a point in taking that forward is to get the funding to support development of the system, but also the associated platform. You develop something that works. So, for example, in its strictest form, EOSC requires the use of environmental descriptors retrieved from satellite data, and they can be continuous, like canopy cover, or thematic, like plant species, for example. And capacity needs to be put in place to support the routine retrieval of these, which can be done through the EOSC platform. They could include things like snow hydro period. So, for example, if you classify snow every date, you can actually, over a year, you can work out snow hydro periods. So capacity for doing that, or machine learning to do plant species, all these can be done, some of them already in the VL. But again, there's lots of elements that can be brought together to create something which is much bigger and much more powerful. And this is the sort of thing that EOSC is really good for. So if you could do that and make sure that infrastructure is maintained, effectively get the funding coordinated around this concept, and then the full functionality of land cover and change monitoring could be realized. And then also bring in data from other sensors, you know, like we've got Sentinel-1, Landsat as well, is also a huge benefit. So there's lots of capacity to expand it. But what's nice about it is that you can get one group working on hydro period, one on like bringing in Sentinel-1 and so on. And it's almost like building a big system through the one system, the platforms that we're developing. So it has been designed with this in mind, but continue to develop the system and the associated infrastructure is needed to create and deliver the advanced products to European, but also the global community. So one of the things then is that providing opportunities for continued and long-term funding of workable solutions is also important, as these often take time to develop and mature. As I said, EOSC is expandable. It's a workable solution, but but to have something which continually relies on small amounts of funding to build something which is actually quite large and could have a real impact is really needed. So it's a combination of funding, infrastructure, and I said before, people to actually be able to know how to use it and to access it and so on. So it's an incredibly fantastic system, but it needs feeding.
Yeah. I think you have, in essence, a similar message that science and policy making can be empowered by data and the complex infrastructures, but this requires a lot of dedication and effort and sustained funding to make it work for the user. So thanks for these comments. I don't see more comments coming through the chat, which is good because we are over time. But for everyone who is connected, I hope you enjoyed, as I did, the science and the challenges for environment that we have discovered today with Alexandre and Richard. And before I hand it over to Sara for a final announcement, I'd like to just give a few thanks. And first of all, to our project management board with Per Oster leading it. When we have discussed the conference and what to do with that, they have been enthusiastically supporting the idea of a digital conference. This has required effort on Trust IT to put everything in place, the presenters, and we were not too sure about how successful this was. It was the first time. I think it's overwhelmingly successful, and we have enjoyed the large audiences in many sessions. So thanks for these efforts, for this support from the PMB. And I'd like also to thank specifically Sara and the team at Trust IT for the dedication for this conference to make it happen, and making sure that all the technical part, which is not visible, would work seamlessly. So thanks a lot for that, from EOSC-hub, the consortium, and everyone who attended these 2 days. And with this, and with a virtual applause for the audience and for the speakers, I'd like to give the floor to Sara for wrapping up the session.
Well, thank you very much to you, Tiziana. You also were very much behind the scene. And I also would like to add extra thanks to the communication team of EOSC-hub, Dimple, Julia, Rob, Diego, and my other colleague at Trust IT, of course. And clearly, I want to thank all the chairs and the speakers and the EOSC-hub work package leaders as well for the huge work that they've done. So before closing, as I said before, and Tiziana announced, we have a final announcement that now you will see on the screen. So we want to announce the final EOSC-hub event that will be organized together with the SHOCK, which is a cluster for social sciences and humanities, and the Freya project, which is the project working on PIDs. So we are working right now on the agenda. The idea is to have a 3-day event in Amsterdam on the week of the 16th of November. We will announce a save the date soon, hoping that this COVID situation will be over. Otherwise, I think after this very successful experience, probably we can go virtual as well. The idea is that the event will open with the SHOC Stakeholder Forum event, so targeting very much the social science and humanities communities, where EOSC-hub will also showcase the specific thematic services serving this community. The second day will be mainly dedicated to the EOSC-hub results, and the third day to the Freya results, as Freya is finishing in November. Say that, I just want to remind you all that all the presentations are online and linked to the agenda on the EOSC-hub website. The recordings of the sessions will be also soon available online. And in 10 days or a couple of weeks' time, we will also share with all the participants the latest edition of the EOSC-hub magazine that will include an article, a post-event article. And for that article, it would be great. So if we could have, if we could take a group picture right now. So if you all can turn on your videos, so we will try to make this experiment, and we will feature this in the EOSC-hub magazine. So I give you a couple of minutes to turn on your videos. Okay, I see many faces there. So I wait the green light from my colleagues. Are you taking a picture now? So please smile. Oh, nice to see all these very well-known faces. So this takes a couple of minutes because there are still many people connected. So stay with us for another couple of minutes. I think that we are done. So with this, I wish you all a nice evening and a long weekend for those having one. And see you in Amsterdam in November. Hope so.
Goodbye,
bye-bye.
Everyone.
Bye, thank you.
Everyone, well done.
Bye.